session. Then we have the actual session when Ifeanyi is going to be talking to us about the topic. And then we'll have our question and answer, then announcements and wrap up. And also, if there's more time, introduce the community to us again. And yes, this is the title for our session today. Beyond DSA, beyond software engineering, its role in machine learning engineering. Like, I mean, there's a whole lot of questions on my mind already. Like, I've heard people on Twitter say, you don't need DSA for this, you don't need DSA for that, or DSA doesn't even, but how is it applicable in machine learning? Because to a great extent, I believe that, in machine learning, you don't need DSA. And I've heard a lot more people say that, but then again, like, everybody does it. I believe there are ways to apply it in ML, and that is why I really want to learn it. So I'll start implementing. And if you know a little bit about our speaker, if you know Agbara Olusheye, she's a machine learning engineer. She is the lead for this community, So, and she writes code and enjoys experiencing life. By experiencing life, I believe she means, write code here, travel there, read maths there, and all of that. I want to believe that's how she experiences life. So yeah, thank you, Ifeanyi. I will just hand over to you.
I don't know what you mean by travel. I've not been out of this place before, but yes, I'll be starting my session. Let me just give me like a minute. Let me just get my screen. I share my screen actually. So yeah. Thank you very much everyone for being here. And like I said, my name is Ifeanyi. I go by Ifeanyi basically most times, right? So I'll be talking on DSA beyond software engineering, and this topic is a topic that is very interesting to me. Why? Because a lot of people, or rather, what brought about this topic is that I've heard a lot of people mention that as a machine learning person, right, you don't need DSA. And I used to believe it before, but I was like, nah, this can't be, this can't be real, because DSA is not just for software engineers, it's not just for code. So in today's session, I would be, going over what DSA is, and how DSA is actually being implemented in this our everyday life, both in software engineering and in machine learning. So I hope, like, at the end of my session, everybody is going to have one or two things to take away from here and learn. So let's start. So I go by Ifeanyi. I think I've explained all of this already. So if you ask about me, this is just like an overview about me, and yeah, everything about me basically. So I don't need to go over it. Yes. So I wanted to start very dramatic. So imagine they employ you somewhere and you are building a recommendation system like maybe Netflix, and you have 200 million users. That's a very great thing for your business owners, right? And then they say, we want you to give us or give the user anytime they log in. Basically, the way Netflix works, right? Anytime you come up on Netflix, you see some recommendation of like maybe top 10 movies you should watch, or top, all those kind of things. And then it sounds simple, right? The only thing you just have to do is that you just have to look through all the 100,000 movies that you have, and then maybe get the thing. But then there's a catch to you doing this thing. You have to actually give your user in 10 seconds. 100 milliseconds should be 10 seconds, I believe. And if not, the user is going to start.
Is it just me, or I can't hear Ifeanyi?
I can't hear too.
Ifeanyi, I can't hear you. If you still can't hear you, okay. Yeah, I think she's working on it. Don't worry. Joy is coming. So while we are waiting for Ifeanyi, maybe I can speak briefly about the community. So this is ML Lagos, and what we are focused on is talking about ML. We are looking towards more technical stuff, things that are more hands-on. So if you really want to get to know the difference between supervised and unsupervised learning, I wouldn't say you're in the wrong place. I mean, you might network with people and grow as a community and learn from others, but we want to look towards things that are more hands-on and applicable in our workplaces or in whatever projects we might be working on. And ML Lagos, I would say it's kind of like more Google related, so more like a spin-off for from I can't find the right word now, but if we'll be talking about cloud concepts or how to apply ML in the cloud or how to do this or how to do that, we are going to be using more of GCP because it's kind of like a community that's spun off out of a Google community. So yes, we are working on a whole lot of technical things, not beginner stuff. So, but if you really still want to, you are finding a roadmap or somewhere to start. I mean, that's if she's the lead for the community. You can always reach out to her and she'll provide you with a roadmap. So yes, I believe okay, Ifia is back on. So Ifia, you can share your screen again. Yeah.
Yes, sorry, it's emptying. I don't know what happened to emptying. They decided to strike when I said I should have call. So let me go back to sharing my screen. 1 minute. Okay. Is it PM beg MTN so that they'll not embarrass me again? Okay. So I think I remember where I was. So I was talking about um you as a machine learning engineer, right? You have this and you're asked that, oh, okay, you should you should do all of this that I've mentioned. And now you have only 10 seconds. 10 milliseconds is like 10 seconds, right? You have 10 milliseconds to accept all of this and show your user. So how will you do it? Um, what is going to happen in this 10 milliseconds, right? You have to search like the user's viewing history. You have to find the similar movies that exist. Then you have to rank it, and then you have to return the top 10. So imagine doing all of this without a proper structure or like a set of process, right? It's going to be very, very stressful. And when you use the right approach like LSH, I'm not here to explain what LSH is, but you can like check it up to search for the nearest neighbor. You'll be able to do this in milliseconds. And you might look at, oh, what does this mean, right? How does it have to do? It's an algorithm, it's made up of data structures, and that's how data structures enter into machine learning. So data structures is not just about, or rather that problem, it's not just a software engineering problem or a machine learning problem, right? It's both of them because yeah, on the software engineering part, you're trying to ensure that users can, have interaction with your idea. And on the machine learning part, you're trying to get the most reasonable thing for your user, hence both of them. So when, as machine learning engineers, or let me just say AI people, because I think I'll use AI people because we have like a lot of people here. So AI people, when we focus on building the architecture or shouting that, oh, we are doing so many things, there's a difference that works, or there is a difference with a system that works in theory and that works in practical and production, and how you structure your process or how you structure your data. So today, what are we going to be looking at? Nothing much really. We're just going to be looking at what are DSAs, common misconceptions, how DSAs fit into machine learning, from data to production. So I'm going to be taking you like some of the common things that is being used in data structures and algorithm, how it aligns with from data to production. Then I'll just be showing some examples of practical DSAs in machine learning, and then a conclusion. So for those that don't know about what DSAs are, or I'm going to break it. You have data structures, you have algorithms. It's called data structures and algorithm. So a data structure is basically a specific way that your data is being stored, organized in a computer, and how it can be accessed efficiently. So basically, it's just how are you storing your data, how are you keeping your data. So you have examples of this. This include arrays, you have linked lists, you have stack, queues. You have like there are lots. I think there are up to 8 or 9 or something, but these are like the major ones. And this image here shows the data structures and some methods you can perform on it, or some actions you can perform on it. Then algorithm on the other end is a finite step-by-step structure of rules. So for example, an algorithm, for like, I'm just trying to explain it. So an algorithm is basically a step-of-step rule. So I want to cook rice. How do I cook my rice, or how do I proceed to cook rice? The first thing is that I have to get the rice right. Then I don't know, some people don't wash their rice. I wash my rice. I wash the rice, I put it on stove, and I like cook, right? So that is like a step of things that I'm doing, but that's an algorithm for me to cook the rice. So algorithm in sense doesn't mean something too complex, right? It could be something as very simple of how do I come from it. It's just basically I want to move from point A to point B. How do I move from point A to point B? That's basically what an algorithm is. So examples of algorithms, you have sorting algorithms, you have searching algorithms, you have optimization algorithms. They're like tons of algorithms, right? And you can search it up. So this slide is not complete yet. I didn't write some things there, but I want to go over some common misconceptions that I used to believe, and some common misconceptions that is being said. So the first one is that DSA is often seen as an exclusive tool to software engineering, especially when you're doing like your interview or you're building backend systems. So you would know that for people that actively interview, and maybe for foreign roles, you would always see things like, oh, go and learn trees, go and learn graph and all those kind of things. So whenever people hear DSA, the first thing that comes to their mind is software engineering. They don't think of, oh, it's applicable. And DSA is not, it was not built for software engineering or for you writing code. It's like a lot, or it's a like lay down rule for you to achieve anything in the computer science world, right? So we saying, or we looking at it as a tool that is exclusive to just software engineers, or software engineering is something that is particularly, I won't say wrong, but it's not right, right? And then this limited view of how people see things, it's like very somehow, and it overrides the purpose of DSA in this field that we are in machine learning. Some other misconceptions is that I'm just building the model. I don't care about what I'm doing. I just need more compute. So why do you, or what makes you think the difference between, I don't know if this is a proper example. Okay, so for the past 1 week, DeepSeek has been making waves on the net. And what is amusing about it is that we have this model, or this model basically making waves. It is better according to them, or well, I've tested it and it's better. It's better, and the amount of money that was used to train it was not up to the amount of money that it was, like, I think 1/10 of the money they use for training ChatGPT. And you might look at it like, how, why? They used less compute. I'm not sure about that. Don't go and quote me anyway. But basically, I just want to take it into the DSA part, right? So into this talk. So what makes it that, or this is theory purpose. Please don't quote me anyway that if you said this. So why is it that it's like lower, and you have like 50 million to $5 million? So what could happen? They use less compute. Let's say they use less compute, they use less money. It could be maybe the way those people are writing the code. It could maybe because these people are like doing something. Maybe they probably looked at it. Oh, this place that we're writing O of n squared, we should be using O of n or n log n, all those kind of things, right? So all these kind of things, they always come into play when you are having your model there. So you don't need to be hungry on compute that, oh, this. You might have to look at the underlying issue, that what is happening. So those are like there are a lot of misconceptions, right? But I was like, should I add it here? I don't want to scare people away. So yeah, you can search up like many more misconceptions. Another one that is ML, I don't need the maths, or I don't need DSA. I just want to build like my system. Optimization techniques is basically DSA at the underneath, or algorithms on the underneath. So if you say you would not need a knowledge, or you view it as a software engineering kind of thing, I'm out to tell you with my full chest and my mind that you are wrong. DSA is for every aspect of computer science or programming or code. I don't know what you call it, like umbrella. So let's look at from data to production. So in this section, I was meant to write section. We'll explore how DSA is present in machine learning workflow, from processing to your production environment to modern application. So the basic workflow for you having a model is that you get your data, you process it, you perform some optimization on it where needed, and then you deploy it to production so that people would see what you're doing, right? So let's look at how DSA is inside all of this process that we're doing. So the first thing is data processing, right? So data processing is the beginning aspect, right? And the choice of data structure determines how you can retrieve your code, so your data, feed your data into the machine learning models. So for example, you have hash tables, you have trees, all those. When you do pd.read CSV, pd.read underscore CSV or whatever, what are the things behind it? I think I read it one time when I was saying maybe trees or something like that. So those are like, or these are the data structures behind your processing and your storage of your data. So an example is Google Bigtable. You might know BigQuery and all those kind of things. So Bigtable is, it uses TensorFlow pipelines, and it uses a tree-like structure to manage data sets at scale. So a tree is basically, I don't know how to put it. They asked me to come and teach the DSA machine learning, not DSA. But if you want DSA classes, you can come to me. I would give you DSA class at a fee. But basically, a tree it consists of branches and nodes, and it's mostly, or you would generally see it in It just basically has branches. Basically, how a tree is. Don't let me even look for something too far. Basically, how a tree is how your tree in DSA is, or data structure. So you have that, and it is used to keep data properly. So you can access it probably through the depth or through the breadth. So you have those kind of searches. Then so hash table, what is an hash table? An hash table takes a key to a value. So I try to put some code examples here. I don't know how to write code, but I mean I try my best for anything for the community. So hash table uses key to map your value. So basically how your dictionary works, you have a dictionary at home, right? You have the word and you have the definition. That's basically an hash table. And you use it to keep your data. So however, when you want to retrieve it, you retrieve it through the value. Sorry, the key. You retrieve it through the key that you have, and that's how you pick it. And most time it's always an O of 1 on average, because you're basically looking for a word. If you're looking for a word in a dictionary, you just go like O, A, B. You don't like look through everything. Like, how will I put it? You already know where you're going to. So it's carrying the key and then it's just looking for the key. So it gives you like an O of 1 on an average. So in real world ML system, let's look at a feature store. You can use this across multiple models. For example, like that recommendation system I mentioned at the beginning, you can use it to store embeddings, you can use it to store features. Then during inferencing, you don't need to start going through all the mathematics or all the models or the pathway that he has given you. And hash table is just going to give you um this exact thing, your ID, once it collects like what it needs from the user. So a real world example again too is Michelangelo. I sent this link to the group, I think like last 2 weeks, and that was when I was working on my side. So Uber's ML platform, they use hash table to store millions of pre-computed features for real-time and batch prediction. So I don't want to talk too much. I'm going to should I share my slide? I don't know. Give me my slides for a prize again. Thank you. So next one was a tree. A tree is a data structure that allows hierarchical organization of data basically. So you have your binary search tree. So a binary search tree is just like a tree with two like branches like this. So it's balanced and you have like your top node and then you have your tree coming down like this. So I don't know if that was enough justification to show you. So when you talk about like nearest neighbors and all those kind of things, you use trees basically. For example, Spotify recommendation uses KD trees to organize the song embeddings and find similar songs. So when you are using a tree, right, it is in hierarchy. I'm trying to put this in best English, but it's not working. So basically it's an hierarchy, and when you want to search for it, right, all the similar songs, they are going to be maybe on the same level. So each so on a tree, you have like level 1, level 2, level 3, and it goes like that, like that. So maybe on level 1, all the embeddings, they are like similar songs or the embeddings of similar songs. So it just does maybe a BFS or a DFS and it gets you all the similar songs. And you're wondering, why is this thing giving me similar songs? They used that kind of thing for it. So it's not like magic, basically. It's just proper use of data structure to give you what you need. So I think that's also algorithm optimization. So after you finish all this, your feature engineering, you do your cleaning, you do your pre-processing, and now you now want to use your algorithm. So you do things like sklearn, you do things like use things like sklearn and all those kind of things, right? I don't know code, so I can't give proper examples. So these things they take in a lot of data, right? You wonder how it takes in all these embeddings, it takes in all these things, and is able to give you, or is able to understand it or work fast. So what's the underlying concept around these algorithms that are being given, right? You have dynamic programming. This is something I personally run away from, but it comes bites me back in my leg. And you have graphs. These two topics that I'm talking to, I want to explain now. They are the topics that scare me in data structures. So you have dynamic programming in Beam Search. I think I can't remember where I got Beam Search from, but it uses like priority queue. You have priority queue too. It's a kind of queue, and it's like stores the top case sequencing, and it gives you the results at each step. And also you have page rank. Page rank is, I think, is for Google search, if I'm not mistaken. So it allows you to rank nodes, and that is like the web pages product for your recommendation system. So what is dynamic programming? So it's an optimization technique, or yeah, it's an optimization technique for your, for in machine learning, not in machine learning, in DSA, where you break your problems into like overlapping problems. So you try to find um I commonly look at it like recursion, right? So you have to find the base case and you now build upon it. I sometimes I call it a special form of recursion because it gives me that kind of vibe, right? So you use it, you break your problems, and it's like you are running. Yeah, it's basically, to me, it's basically a recursion that you're just trying to, get the answer, and you find yourself in a loop where you have to hit the bottom, and then when you hit the bottom, you already have the answer, and it just starts coming up, coming up, coming up, and you find the final answer. So I hope that explanation made some sense. So sequence models is, or sequence model, they use dynamic programming. So they find the most probable sequence of the hidden states, and I mentioned Beam search again. So real world examples of dynamic programming, you have speech recognition systems, and you have your machine translation task for sequence alignment in text. So I think that relates to NLP people. So graphs. Graph is a data structure that consists of nodes and edges. So before anyone asks, yes, a tree is a special type of graph. I think is cyclic. I'm not sure again. Well, yeah, I think so. But it's a special type of graph, right? And it is used. Graph is like one of the things that is mostly used in like neural network. Let me just say neural network. Graph and neural networks are like 5 and 6. They mostly use them. So a use case is the GNN. So you have the GNN. I'm not sure of CNN. I don't want to shoot myself in the leg. But basically neural networks are they mostly use it for anything network analysis, right? You use graphs for it, and that is one of the best things that graph has to offer. So you wonder how, like I said, you wonder how this thing takes in all of what you are giving it, and is giving you, is making sense out of it. It is because of the underlying algorithm and data structure that it was used to provide. So it was used to process what you have and get your result. So that means you can always go into the system, arrange the structure as you like, and get better results. So it's not magic when people do it. So please, I hope people, as I'm going through, you're looking at an example of what I'm doing, because I can't go through the code and go through all of this. So an example of GNNs or graphs is social network. So things like X or Twitter, basically any social network, they use graphs. So how do they suggest your friend? How do they suggest your enemies? How do they suggest your topics? How do they suggest basically things that are close to you, or things that you might want to, be interested in? They use graphs. So they already have like everything arranged on your the nodes, and everything is basically intertwined. The closest to definitely stay near each other, I believe. And moves on like that. And then molecular graphs, if you are doing something like chemprop, all this, we are working with molecules, so chemprop and the likes. So you use the embedding of like your what do you call this in chemistry again? Your compounds, you compute it into like the function, and you get like you basically get, I think, an embedding. I've not used chemprop properly before. So you, but I know it's being used because you have some graphs. In fact, you will see it there that is literally named graph after like the graph data structure. So you have other things too that you can use. Basically, just any neural network that you think they use graph underneath, and you can always go into the source code and look at how it's being done or how it's being implemented, and take a simple implementation of a graph, place it hand in hand, and you look at how it's being implemented. There might be some extra one or two things there, right, that they will add, but the principle or the idea is going to be the same. So so modern applications, right? So after you finish all the model building and everything, so you need you will deploy it, right, and you have an application. So ML architectures are evolving rapidly. People are discovering things, people are researching, they are bringing out things, and this, their effectiveness depends on how you apply your DSA. Because imagine I want to treat a neural system, and I now say, oh, I'm going to use a list to do it. It's going to be so hard. In fact, the compute is going to be so high, or it's even going to be impossible, because they have, I can't imagine how you want to, treat such amount of data that is coming in and say, oh, okay, you are going to now use it to decode and do some analysis, and at the end of the day do some prediction. It's going to be so hard, right? So ML systems like transformers, GNN, and the likes, they use DSA to address the challenges such as scalability, like I just mentioned. You can't say you want to use a list where you should be using a graph, because it's going to give you a lot of compute issues, and probably it's not even going to be usable. So efficiency, where you're meant to use maybe a dictionary for lookup, you should not use maybe again a list, or maybe I meant to use a linked list, you should not use a dictionary, all those kind of things, right? Those are the things that come into play when you are building this unit. And also you might ask, oh, can I use more than one or two data structures when I'm doing my algorithm? Yes, I believe, because data structure is just like a bunch of principles. So you can say, okay, maybe in this particular point, when I'm retrieving my data or when I'm doing this particular thing, I'm going to use a stack. And when it's coming into this part, you should use a graph. And when it's coming into this part, you should use a tree. So it's up to you, basically, right? Yeah. So you have transformers. I'm going to talk on transformers and their attention mechanism as a DSA problem, and graph data structure in GNN. So this popular paper where they say attention is all you need. I don't know if anyone knows the paper. That's the paper that brought about all these wonders we're having, the GPT and the likes. Well, if I'm wrong, Shai, I can just say it in the comment section. I don't know if it's so yeah, the implementation of attention skills, or the implementation of this transformer, was originally O of n squared due to the computation they were trying to do alongside with the attention score. So after that, they now looked at it that, okay, instead of us to do or to be running our code in an O of n squared kind of thing, let's remove those extra, or let's find a better way to do it. So I can't really say how they did it, because I don't work at Google, or I don't know anybody that did what they did. But reading up on what they did, they used things like heaps. Oh, I didn't even mention heaps. They used things like heaps, hash map for their ANN in each of these attention or span attention mechanism that they have. So models like OpenAI, GPT, BERT, Gemini, and the likes, they rely on this kind of optimization because they are using the same underlying process or the same idea. And since it was optimized in the paper, I believe, it was now used for basically building this GPT. I think GPT means I don't know the meaning of GPT. I can't remember. I'm tensed. So basically, it was used to train to have these like big models that we're using, and you'll be wondering, oh yes, this makes sense and it's very very good or it works properly. So yeah, generative pre-trained transformers. Thank you. So look at the next one. So graph data structures in GNN. So you have things like the traversal algorithms, you have things like the sparse matrices that are being used or are being mentioned when you mention GNNs, and the real world cases of this, like we saw in the first time when we saw social media, we have drug discovery. I've mentioned, I feel I'm still even mentioning this drug discovery because drug discovery you would most likely use to like chemprop. It's only chemprop that comes to mind whenever I talk about things relating to molecules. And then fraud detection. So if you are a fraud and they'll be looking at this person, you are doing too much money in a month, or I don't know. Someone like me now, they can't even detect me for fraud because there's no money to spend. So payment networks like PayPal use GNN to detect fraudulent transaction. So when they start analyzing through using graph, so I really can't explain like how graph works, because if I do, I'm going to leave you more confused than how you know it or how you don't know it. So I'll just suggest after you read the time. DSA is a very interesting it's a very interesting topic though, but you should like have one or two things to do with it. So how does DSA, so after all these, since it's like I've been speaking like different places, so how does DSA fit into machine learning, right? It relies on these patterns, sorry, yeah, it relies on these data structures, or it relies on these algorithms to learn patterns from your data and make prediction. So ML or your model is not a black box, because a lot of people will say, but that's what brought about XAI, and I mean explainable AI. So we're trying to explain how your AI model works, or sorry, how your model works, right? So it's not entirely a black box. It's only a black box because we are lazy to sit down and look at what it's doing. So ideally, it's just pattern and some basic things that if you have time you can look at it. Even the mathematics set is written in such an optimized way, and that's why you have it work very well. So the entire process of training, evaluating, optimizing is rooted in the way you design your algorithm. So it's not like those people are doing magic. Basically, it's just because they took their time to understand their problem that they're trying to solve, look at the best way to optimize it, and then write the code for it. So they don't just write like for loop everywhere or write if statements everywhere. So concepts such as tree, graph, and heaps, they are like the major backbone of these ML algorithms and ML models that we use, because they are best fits for the kind of data that is coming in, because you know the kind of data that is coming. So I was reading somewhere that DSA really matters in machine learning because in software engineering, your problem is like deterministic. So you already know this is what is coming in and this is what is going out. But that's not the way they put it before you attack them. They put it in the sense that, or how will I explain? You already know like the constraints you're expecting, or to a great extent, you know the constraints you're expecting and you know how to work on it. But when you are treating um what they call it, when you're treating machine learning, you don't know the kind of dimension your data is going to come in or what you're going to do. So that's why it like matters, or that's why it fits more into machine learning than software engineering. But I don't want the software engineering guys yet to come and look for me after I write. I'm a software engineer too some days. So practical application of DSA in machine learning. This one is very good. It's going to be very quick. So we have tree-based algorithms. I have decision tree. I have random forest. So I just basically shared graphs on how these things work, right? So when you hear tree based, you have decision tree, you have random forest. So um these are like algorithms. I'm just scared that I want to be using the right words. I don't want to be misquoted somewhere. That if said random forest is a method or something. So whatever random forest is, whatever decision tree is, we all know what it is in the ML world, I believe. And this is what they are being used for, or the applications are linked to these algorithms. So when you are doing a classification or regression, is a decision tree kind of thing, and it is tree based. From the name decision tree, should have given the way out. And random forest, I think of random forest like a forest has so many trees, so it's definitely a tree based algorithm. Thank you. That's the best way to remember. So graphs, you have GNN, you have the shortest path, and these are the ways, or these are the practical applications of DSA in, or graphs in real life. Then you have heaps. So you have the A-star algorithm. This thing, they asked me to learn it in school. I ran away from it. So autonomous vehicle routing, you have gaming AI, and you have robotics. So you speak about this a lot when you're talking about the A-star algorithm. So you'll be hearing about these algorithms, right? And these are like the data structures, or yeah, data structures behind them. So you have hash table. So you have things like all of these mentioned. I feel like I'm reading it to you. So yeah, you can just check it out. Things like feature mapping, data retrieval, like I mentioned at the beginning, the whole thing about the dictionary and the word you're looking for. Algorithms used in ML. So things like divide and conquer, dynamic programming, reinforcement learning, greedy algorithms. All of these are algorithms that are used in machine learning or in the ML space. Yep. So I think that brings me to an end. I have yapped a lot. So my conclusion is that DSA is the foundation. It is the bridge between this theoretical ML concepts and real life or real world applications. DSA is not just limited to software engineering. They play very, very key and pivotal role in the ML world. You can find the practical applications of DSA in libraries, and you can use these things that I have explained today to improve your tool that you're building for your user experience. So taking away from taking whatever you'll be taking away, like your takeaways, learn DSA today, no matter like whether you're just starting out or you're just doing something. Learn DSA today, experiment. You need to experiment a lot, like experiment a lot of things. And when I mean experiment, right? Go into the source code, look at what it is. A lot of people, from my experience, they fear about, or they have this fear about going into the source code. But I promise you, going into the source code is beautiful. Experiment. Okay, these people did something here, and that's how you learn really. Like when you experiment, because there's something, I don't want to use curse words here, but I mean the FAFO method works a lot. You should try that out. And then build. So after you finish experimenting all these things, try and build with it, right? Build and just learn and just build. And I promise you, uh it's not the same code you're going to be writing as someone who doesn't know DSA. In fact, DSA doesn't, funny enough, DSA is not just limited to code per se, right? It affects your way of thinking, like your thought process. So you don't just think in a very scattered way. DSA will make you think in a more structured way. And as a machine learning engineer, that's what you need to be able to fix your issues, to provide the best of like what you're writing to people, so that they would know that what you are doing, you are not giving a model that when you are testing it or when you are using your test data set is giving you, 98% accuracy, and on the real life data set or in real life is doing like 50 something. What's affecting that is some people say, it's because of overfitting, it's because of underfitting. Yes, those have their rules inside, but having these having these ideas, no, not ideas, having this knowledge, right, about how to use these tools or how to implement these algorithms properly affect the way your data is being even processed or being trained. So yeah, learn DSA today really. And that's what I've been trying to do since the beginning of this year. I've been on this code, I've been solving questions every day. A lot of people have been asking me, oh yeah, solving this code, does that mean you want to enter the job market? Not necessarily. I also feel like solving these codes, like, makes you into sharp. If you are feeling sleepy in the morning, open these codes, like your head is going to come up like, Jesus, what's happening? Open Akara, and do those kind of things, right? To tune how you think. So you won't think haphazardly. Yes, that's what I was looking for. DSA makes you think in a more structured way, and it also affects your life, not just code wise. Because when you're able to think in a in a more structured way, it also affects like your other life. So DSA is like that life changes, like the Holy Spirit. It affects you positively. So yeah, I think that brings me to the end of my session. Any questions? By the way, I'm sorry that I did not write code today. The thing, I don't have to write code. I don't want to embarrass my lineage. I don't want to embarrass my family name. I don't want to embarrass myself. So I'll say I just wrote those code, I just showed you. But next time when I learn the process or the art of writing code, I would show you as well. So I think I'll take questions now. Thank you very much. You can contact me for anything in the group. You can send me a WhatsApp message. I try my best to reply WhatsApp messages. Yeah, I'm very approachable, right? You can approach me, and at the same time, if you come with, a very bad vibe, I would give you the same bad vibe. So yeah, proceed with caution when you enter my DM. Go straight to the point, and I'll answer you. I'm a very nice person. A lot of people believe I'm not, but I mean, I say that to make myself happy. So again, you can reach me on Twitter and LinkedIn. LinkedIn is the worst place to reach me because I don't open that app like it's like every 2 months. But I'll try my best for the love of people and open it. So thank you very much. I would take questions now. Yeah. So you can just like raise your hand or you can drop your question in the chat section.
Hi, Fiona. Thank you very much for today's session. It has been very insightful. But me, I have my own questions, and I don't know what we are waiting for other people to maybe raise their hand or ask a question. So here goes my question. So I was going to say, does it mean that if I am using the tools, like people have written this algorithm on the back end, that how Panda works, how decision tree works, and all I am doing is just take pandas and do pip install pandas, pd dot read csv, or just random forest fit or random forest predict and all of those things. Do I still need DSA, or like if I then want to start building some of these tools, like, oh, I've gotten to a point in my career, I want to start giving back to the community. I also want to start building tools that people can use for their day-to-day work. Is it that when I feel like, oh, that's it? Basically, I don't know if you get my question.
Yeah, I do.
Yeah, okay, thank you.
Okay, so I'll start from the first one. So you're just doing like, oh, you're just calling the function, you're just calling all of this. So each of these functions that you are calling, right, they have their complexity that they are calling. So complexity is just the amount of, I don't even know, is it the amount of time? But basically complexity in DSA means something. I don't know, or I don't have the perfect definition. Just give me 1 minute. Let me search for it so that I don't be like a complex, the proper Olodo complexity. in DSA. So complexity is, yes, the time taking. Why was I not scared to say it? It's basically the time taking for you to for your code to run. So you have different kinds of time complexity. You have O of n, you have O of n squared, you have O, you have n log n, you have O, I don't even know, O n cube and the likes, n factorial and all those kind of things, right? So each of these functions, they have their specific runtime, and you might want to look, okay, this code that I'm using or this thing that I'm using, what's the runtime? You necessarily don't have, they will not write it there inside the doc string that it returns, or this is a O of n complexity, right? They would just tell you it returns XYZ. So it's when you have this understanding of like DSA, or the basic, more specifically, the understanding of complexities, you'll be able to know this is what this returns for me. So will I want to use a maybe dot sort instead of a dot sorted? Because I know I had that particular problem before. My solution was given an O of n squared, and that was because I was using, I think, a dot sorted or so. And then my friend was like, use a dot sort. It's like, I can't remember the exact thing, but I know it was different, and when I used it, it changed the amount of time my code used to run. So I would say yes, you still need DSA to do what, or even if you are just calling a function. So it makes you look at what are these functions. Okay, this function that is giving me O of n squared, what can I pair it with, or what can I use it with? That's number one. So if you are now saying, oh, you want to give back to the community, you want to start writing your libraries, yes, you need to understand, because if your code spends a longer time to run, promise me, people are going to shit on you, on your issues. They're going to talk bad about it, especially if they do not like you. So you need to understand this. You need to understand DSA so that you know how to structure. You know, I said DSA like gives you it gives you a proper way of thinking. So all the things that you should have done at the beginning before, if you don't like have like a good understanding, at the end of the day you might end up going back and forth, back and forth. I'm not saying that DSA is like the ultimate solution of you fixing something, but basically it's going to give you more edge on starting out like what you have on ground. So you don't have to say, oh, we're implementing this in ABC, or even if you're implementing in ABC, it's going to give you in a better way, or you're going to have better options or better implementations of that. So yeah, you need to have like a good knowledge of it. So it's not going to look like an amateur that is writing code, because when you are giving back to the community, especially in this ML space, it is believed that you are of you know, high intellect or smart. So you want your code to look smart. Let me look smart, let my code look smart. So yeah, that's a reply, or some replies to your answer. So to your question, Jesus. Okay. All right, Chiweze.
Oh, hello, good evening. The name is Chibueze. So, thanks a lot for the talk. What I want to ask is that please, how can an ML engineer now who has limited data structures knowledge at the moment start incorporating this idea? That's the baby steps into their work. What would you recommend?
Okay. What I recommend, the first thing I'll recommend is that you first, learn DSA, learn data structures, learn all those things. Then the next step I would say is try to be conscious of what you're doing. So let's say you learn about trees today, or you learn about lists today. You look at what you are doing or what you are going over that day, and look at, okay, is this a tree? Is this a list? How do they implement this? Or you look for functions, or you look for algorithms that use that data structure that you have learned, and see how they do it. So with that, you're not just expanding just knowledge, but you're already looking at practical applications, and it will make you question the structure more, and you continue to go, or you continue to deep dive into it. So from there, you won't just have like a limited knowledge again, but you have like understanding of that structure, and you can explain it, or you can even implement your own as time goes on. So I'll say that is one way. I hope that answers the question.
Say thank you very much.
You're
Yes, it does.
welcome. So any more questions? So I'll take that as a no. So over to you, Balaji.
Yes, thank you everyone. Thank you, Fion. It was such an insightful session. As you can see, even me, I had to jot things down so I could, take things away. Yeah, you can follow us on Twitter or LinkedIn, Machine Learning Lagos, or ML in Lagos. And if I don't know if you want to just talk for, I would say 2 minutes about the community. Yes, just like she said, can I still be added to the ML Story group? Okay, okay. If that question is for you, but yeah, can you just introduce the community quickly for like 2 minutes to everyone again? Thank you.
Okay. Sorry, I'm still sharing my screen. Let me stop sharing. Just give me 1 minute. Stop sharing. Yeah. Before I answer your question, so I'll just like take it over from you. So because I have some explanations to do. So yeah, please follow us on Twitter and LinkedIn. I'm begging. I'm not proud this time. So yes, follow us. Next slide. I don't think I have the slide open. Okay, so yes, we're having office hours. I don't know, does anyone know what office hours is, or what this plan? Has anybody even heard about it before? Before I even like start? If you've heard about it, you can just like do some reactions or something. Huh. So just two people. So our office hours is a bi-monthly session, right? uh it's a bi-monthly session, so it happens once in 2 months, where we bring like GDs and Googlers. So it's kind of different from this our session. These people have an idea because we are a Google-based community or third-party community. So we're trying to integrate their technologies, because Google has one of the most they have one of the most wonderful technologies out there. If you want to argue that with me, you can schedule a time on my calendar, and we can argue it out, and I'll explain to you why they have it. Because I am a Google Diet fan. Yeah, I have to put it out there. So they have one of the best like technologies out there, and we want to bring these technologies closer to people. So what we plan on doing is having office hours with these people, where so where we have people to, we have these Googlers and we have these GDs come to explain these things to us. So we're having our first session, right? And our first session is in February 21. I will drop the link here. Please, I need people to attend or come to this session. So we are having GD. He will be taking us between jacks and flags. So yeah, you can come and have, or come and enjoy yourself in this session. Yes, thank you very much. Then study groups. I'm going to study groups now. We have closed the registration, right? We're not opening it again. If you want me to open it for you, we're gonna bring 1 million naira. So and I'll open it for you. Thank you. So the onboarding will be happening this weekend. So you'll be receiving an email either tonight or early tomorrow morning about the onboarding and everything that's going to happen. And yeah, we'll move on. I hope everyone has joined the group because we sent emails out to everybody, and feel free to reply to the email if you like if you need more information, and the people in charge will answer you. So now, can I still be added to the ML study group? You registered yesterday. If you registered, please check your email for the if you registered for the study group. Please check your email. You've been like you would have sent an email. If you didn't see it in your inbox, check your spam. And can you be added to the study group? At the moment, no, till next cohort. The next cohort should be happening later in the year. But I mean, if you're in the community, we have wonderful people there that know what they are doing and they'll be able to put you through. So yes, I've answered the 2 questions. Thank you very much. Next slide, please. So yeah, we like your feedback, right? And we collect feedback after every session and basically after everything that we do to know, oh, what can we do better? Do you want us to bring Sunda Pichai here? Do you want us to bring Francis Schuller? Who do you want us to bring? Or what do you think we can do better? Or maybe you can say that, this person, like if Fiona, she's not teach very well. So we want better people or more technical people, or many people that have just anything. They have questions there that you can share your thoughts. It's anonymous. You don't need to worry that I will come and be pushing you, but I will know you if you say bad thing about me when I check it. But in all sincerity, it's anonymous. Just put what you want to put there, and the team will review it and see what they can do better. So yeah, I think that brings us to an end, right? So last slide. Let me see if there's anything. Yeah, that brings us to an end. Please, follow us. Come for our office hours. Don't worry, it's not going to be a Google Meet. It's going to be like YouTube Live. So you don't need to worry yourself. Follow us, do all those kind of things. And I promise you, we'll continue to give the best and the best and the best until you'll be like, God, these people are giving too much. I can't handle it anymore. Yes, that's what we're planning on giving you. So, yes, thank you very much, everyone. Study group people, see you on Saturday. And for the rest, see you in the next office hours and the next technical session. Okay, yes, Balaji.
Sorry, mistake. But what I was going to say is I was wondering if people can turn on their videos so I can take a nice picture. But then
Oh,
I'm
you want to
worried
take
that
picture?
the lights.
Yeah, no. Before they can take my light. That's nice. So I don't want doing the screenshot on your end because my screen is small.
Okay, I will do it from my end then. People can turn on their videos if they can. 1 minute, because just 1 minute to turn on my video too.
Let me see if I can actually change the tiling. This is too hard though. Oh, change layouts. See me.
Yes, I have changed the layout to take more people. I changed it to tiled, and I increased the number of everything.
Yes.
So guys, let's turn on our video. See my small head. Okay, 1, 2. Okay, so yes, got in. Thank you guys.
I'm smiling too much. All right, thank you very much, everyone. Bye.